Hi, my name's Mark from ITCU Solutions, and today I'm going to show you guys how to set up a LAN-to-LAN tunnel with both a Cisco router and a couple ASAs. And here's the steps we're going to go through. Step number one is you configure the ASA policies. These are just your security protocols that you need for the two devices to negotiate to create a secure tunnel in order to actually negotiate and create the protocols needed for the second tunnel. And what you do in the first one, of course, is you have to create the encryption algorithm. Actually, we're going to set this to AES, just 128, standard AES. And then you have to create a SHA, or a hash algorithm, which can be MD5 or SHA. We're going to use SHA. We have to specify authentication method. In this case, we're just going to use pre-shared keys to keep everything easy. A Diffie-Hellman group identifier, a security association lifetime. We're going to set that to 12 hours. Generally, you don't want to set that too short. By default, it's 24 hours because there is a fair amount of stress on renegotiating those keys every so often, or those parameters for the whole security association. So generally, they're usually set to 24 or 12 hours. I probably won't set any less than 8 hours. Then the next step is we need to create a transform set. That transform set is actually what this Ipsec part of this handles, the phase 2. And that transfer set is basically to set up the protocols for encryption and to authenticate the phase 2 packets, generally for ESP. It can be for authentication header, but it's very unlikely you'd ever use that. The third step is to configure an access control list. This is to define the interesting traffic that you want to be encrypted. In many ways, it acts like a route map. It determines what gets routed over the tunnel and what doesn't. And the fourth step is just to create the authentication key, since we're using pre-shared keys. You do this on an ASA through tunnel groups, and it's slightly different on the router. We'll go over that. And then the final thing is that you just take all these things, you apply them to a crypto map, and then you apply it to an interface. So let's get started. Let's take a look at our configuration. This is what our test lab is going to look like today. We just have a Cisco router up here. In this case, it's Cisco 887. And we have two ASAs. We're going to set this up as a hub and spoke. This is commonly how we used to do this with our clients. We have a main router, sometimes an ASA. We have our client routers out there. They can route back to our main router, in this case, the Cisco 887. And these would be like clients. And so we'll just have tunnels only established back to us and not between the ASAs. For your setup, if this is just for your own company, you might want a full mesh network, where in other words you'd set up LAN-to-LAN tunnels between everything. Okay, so we'll get started here just so you can see the IPs here. We're going to generate test traffic from these internal interfaces instead of from the host, just because it's easier, and I'll show you how to do that. Okay, so let's get started. We'll start configuring on our ASA, one of the ASAs here. We'll pick ASA Firewall 2 over here. And we'll just do that to keep these up. So the first thing we're going to do, according to our steps, is we're going to define this ASA policy. Okay. Okay, so let's do that. And this is a newer ASA, so we're not going to use the ISACamp command. It's been replaced with this Internet Key Exchange version 1. So we'll do that. The first thing we got to do is enable that on the outside interface. If you're using phase 2 as well, you'd do that as well. So you'd add crypto IKEv2 enable on outside as well, if you want to do both. If you have clients that some are using IKEv version 1 and some are using IKEv version 2. So that's the first thing we do. And then we're going to actually create the policy. And since we're only going to have one policy on here, we're just going to call it policy 1. You could have multiple on here because you might have clients that use a different grouping of authentication types and SHAs or whatever you're doing. So we're going to use pre-share because we said we want to keep this simple. So we're just going to do authentication pre-share key. We're going to use encryption, just standard AES. 256. Okay. We're going to do some people use higher level hash algorithms than this and Diffie-Hellman groups, but because we're using an ASA, we can't go above a Diffie-Hellman group 5, at least at this on these ASA 5505s, at least for this firmware that we currently have. Oops. I meant to put hash SHA. That has to be MD5 or SHA. The Diffie-Hellman group, we're going to use 5 because we don't have a choice to go higher than that in this case. And then finally, we're going to set the lifetime of the tunnel. And this is just how often that your tunnel needs to rekey. We're going to set it to 12 hours. By default, it's normally 24, and that's probably what you should use. Okay, so let's move on to the second step, which is to create that transform set for the IPsec tunnel that comes up second after we've created the first tunnel under the Ight version 1. And again, these are your protocols that you're going to use to actually encrypt the packets and authenticate them, the IP packets. And let's actually look here. Let's name this. I'm just calling it this because this is the actual parameters we're going to be used, so it makes the easy selection. This is just the name. You could call it anything, but like I said, it's easier just so I know what they are. In this case, we're just going to use standard AES, which is 128. That's why I have it called 128 up there. And then also we're just going to use, whoops, my bad there. And then we're just going to use SHA for the authentication method. Okay, so we have our transform set done. The third thing we need to do is configure that ACL for the interesting traffic. So if we go back to our network, we're on this firewall here, firewall 2. And so we just want to make sure that anything on the 172.16.3 network gets encrypted to go to the 172.16.4 network. Okay. I'm going to do something, to show later on that it doesn't have to, I'm not going to use the class C's, I'm just going to encrypt this with an entire class B because I want to show you a problem with doing this later on. To show you that the order matters when you're setting up these access lists and the way you apply them to the crypto map. So I'm just going to call firewall 2 to router, and we need to set up here. Spelled access list wrong. There we go. Again, I'm just going to call it firewall 2 to router to keep it simple so I know what's going on. And that's a good idea when you name stuff to do that. And we're going to use an extended access list. And I'm just going to set up the class B's here. Networks, which obviously 172.16.3 is contained in, and then I'm going to send it to 172.16.4. Now remember, on the other side, these parameters have to be identical, except for the ACL, they have to be the inverse. So we'll show you that when we set up the router. Let's take a quick look at what I did there. Firewall to router, so we're saying anything on 172.16, the whole class B. Okay, that looks fine. Okay, so we got the ACL configured. Then we'll define our tunnel group. And this is just the peer. So again, if we look over here, we are just defining the peer we're going to connect to. So in this case, since we're over on this ASA, we need to connect back to the router, which is going to be 1.1.1.1. So let me just make sure that's true. I'm sorry, it's going to be 3.3.3.1. It's just the outside interface of the router, which is where we're creating the tunnel to. And you have to call it IP address because we're doing a LAN to LAN tunnel, which is using main mode. So you can't use a name here. The devices will, at this stage, will only see the IP because everything's being encrypted. If you were using quick mode, you can use, because of the way that the initial negotiations happen, it will actually see a name like a username. So if you're setting up a remote desktop VPN or something, you wouldn't have to set up a group with an IP address. You could use a name. Okay, so we're doing a LAN to LAN here. And we just have to define the pre-shared key here for the IPsec portion of this. And we're just going to use a simple one and call it test. Now all these parameters, again, have to be identical to whatever you're connecting to on the other side. So now I'm going to apply them to the crypto map, which I'm just going to make up a name here. We're going to call that one also firewall 2 to router. Whoops. Keep it simple. Then we just got to grab our access control list that we created on the previous step, which we also called firewall 2 to router. Then we have to set the peer, which again is this up here. Oh, I forgot the number. Then we gotta set the peer, which is again is the outside interface of the router. That's who we're building the tunnel to. Then we also have to add the transform set. Which I believe I just called, and again this just matches the actual parameters that we're using in the transform set. That's why I used it for the name. And then finally we just have to apply it to the interface. So I'm just going to go up and steal that. And if you're on an ASA where you're 5505 and you're only using the outside inside interface, you're obviously always going to use the outside interface. Okay, so we're done configuring the firewall, and I would recommend you do this as well where you pull up your commands, because all this has to match the router I'm going to configure now. Oops. Let that die real quick here. Okay. So we're going to go through the exact same steps with the router. Okay, so we got to create the crypto policy. And this has to be identical to the crypto policy down here. Okay. Just slightly different verbiage, but you can see it's exactly the same. Again, authentication pre-shares, so we're matching everything up. Hash SHA. And we're going to use group 5. And basically you could just cut and paste everything you did over here up here. Okay. So that was step number 1. Then we're going to add the Ipsec transform set. So let's do that. And again, this has to match our transform set that we have down here. Right here. It's going to be almost the same verbiage. In fact, if I get from there, skip that key, should be able to just add it, cut and paste it from the firewall up to the router. Okay. And then again, we need to configure the access control list. So I would recommend as well doing a show run access, look at your access list, because this has to be the exact inversion of this. We're going to call this one router to, I guess that's FW2. W2. So I'm just going to really grab that. And these have to be the reverse, so I'm just going to grab the second part of that. Oops, except this is a router, so you can't add a standard subnet mask. You have to use an inverse subnet mask. And we'll do the same on the bottom. Okay. Let's see, permit. Let's go through this real quick. Oh, my mistake, I forgot to put IP in front of it. Again, the verbiage will be slightly different since I'm not using a numbered access list. Then this should all be the okay. My bad. Okay, here we go. Let's go still what we did up here. Okay, there we go. So again, that should have been just the inverse of what we had down here. So we're done with our interesting traffic. Now the next step is we have to do basically what we did on the ASA with the tunnel groups. Okay, so it needs to be the same peer there. Or I'm sorry. We need to connect to this peer here. Okay. And also the peer over here. Okay. Right there. And add the key as well. And we're just going to use the word test again, as that's what we used on our firewall. And we're going to call this 1.1.1. You can see it over here. Okay. And the other one's going to be the same, except it's going to be all 2s. Okay, and then the final step is we're just going to apply that crypto map, add everything to the crypto map, and then apply it to the interface. We'll just call this one 2 firewalls. Okay. And it's just telling you have to add the 3 steps we already did. So we have to add the peer, the transform set, and the access control list for the interesting traffic. So let's set that peer. Okay, as you can see over here. Let's do our transform set. And I think we called it here it is. So we got a transform set, and the third thing you always have to add is in that we have to match that access control list for the interesting traffic. And I think I called it router to firewall 2. There it is. Oops, which we need actually, I skipped a step here. I'll come right back to that. I need to create a router to firewall 1. An access list for it. Oh, which I already have up here. Okay, good. And I accidentally added 2 for the firewall to 2, so let's just keep one of these. We'll get rid of this guy right here since they're identical. Okay. So let's go back to our transform set. And we're on the first entry. And this one was for this peer over here, so we're going to use the 2 firewall 1. Match address. Okay. Okay. And then we have to create a second crypto map entry. I don't know why I'm doing that. Crypto map to firewall, and we'll call this 20, and this will go to our other peer over here. So we're just going to set peer, and this time we're going to use this IP right here, the outside interface. Somehow I ended up outside the crypto map. Hold on a second. There we go. And we have to am I using the wrong name here? Let's see. Two firewalls. We'll do 20. Forgot the keyword there. There we go. Then we'll set the peer, and we'll set the transform set, which will be the same as the one that was on top. And again, we called that AS128 SHA. Or maybe I didn't. Let me go up here. Oh. There we go. So we have our transform set, and the last thing we do is we need to apply that third access control list. So we're just going to match the address again. Except this time we're doing it to firewall 2. So let's go up here. We have it right here called router to firewall 2. Okay, so now we have our entire crypto map. We have our parameters that will allow us to connect a tunnel to firewall 1, and our parameters will allow us to connect this to firewall 2. So the last thing we need to do is just apply it to our external interface. And on this router, that's on VLAN 10. Okay. And up above, I think we call it 2 firewalls. There it is. Okay, so it's applied. So everything's configured on the router now. Everything's configured on firewall 2. I had already configured everything on firewall 1. So when you look at all these, these should all basically be the same on all 3 devices, except for minor differences on the peer addresses and things like that. Okay, so the policies should be identical. This is showing me I got one that's incomplete here. Not sure why it's shown that as incomplete, since we have our peer address, we have our transform set, and we have our, oh, because I got the wrong firewall name there. And again, this is why you should hold them up side by side and just make sure. And that should have been router to firewall 2. So let's do that again. Okay, notice everything's complete now. The peers should match. So this peer, of course, goes to 2.2.2.9 here. 1.1 was over here. All of our transform sets should be the same. As you can see, they are. And our access lists, which we can show again, should be the inverse of each other. Okay, so everything looks good. around here. So what we're going to do is we're going to kick off some interesting traffic to both of these. So let's ping, I'll tell you what, we'll do it from the firewall side. Firewall 2, we're going to ping 172.16.4.1, which is the inside interface of the router. And because we're testing, we need to use the inside interface because we're really going from 172.16.3.1 to 172.16.4.1. If you hit outside, it won't work because that's not part of the ACL that's defining the interesting traffic. Okay, so it's coming back with an error telling us we have something wrong. So there's two things we can do. We can debug this and also just a couple things. Let's see what's going on here. Let's take a look at the security association. So if you see something like this where it says main mode wait message 2, that means that we're not even getting through step 1. If you ever look at the entire process, message 2 is what happens first. So I would guess either there's probably something maybe even wrong with the peer. Could be possibly the access control list. But let's do a debug here to give us just a little bit more information. Let me check my logging real quick. So, okay, ASDM, let's clear that out just to make sure. Okay. Let's do another ping here. Actually, before I did that, I need to turn on, we're not even getting to IPsec, so we're just going to turn on ISACamp, or Ight version 1 in this case, since we're on an ASA, a newer version. So let's ping again, generate that interesting traffic. And we should get some debug information in the ASDM log, as we know something's wrong, because, okay, let's take a look what we got going on here. Okay, so that looks good. It's trying, so you know on your side, since it's trying, that your ACL is correct, at least on the ASA, because it's trying to contact the peer, so it is hitting interesting traffic. So that's a good sign. Okay, we're receiving unencrypted information, which tells me that there's probably something wrong on the ACL on the router or possibly the peer. You're getting the processing failed. But normally when you're getting unencrypted information back, the router doesn't know to encrypt it, which probably means either the ACL is wrong or maybe I got some peer information wrong. Let's see if that gives us any more hints here. Tunnel manager, okay. So the rest of this probably isn't going to help too much. So let's take a look on the router. I think the problem's over here. So let's look at the ACL real quick here. Oops. Well, maybe that's... So let's take a look here. Okay, we're getting hits, which implies that the ACL is correct. And that, so this guy should be working. It looks correct. I'm sure that's the inverse. So let's take a look at the peer information here. Oops. That looks right. Oh, wait a second. Okay, here's our problem. So let's fix that real quick. Okay. So I'm going to guess the other one was actually probably working, which I should have probably checked to tunnel 1. Let's go back here and take a quick look. Let's do it from down here. Oh, there we go. There we go. So now, if you do your show crypto ISACamp SA, You'll see it's in main mode active, which means it's working. And then if you want to just make sure too, you can do this should show you that your outgoing traffic is getting encrypted. So you got packets encrypted and packets decrypted are coming back, and that's the same number. That tells you your tunnel's working. Let's do it up here just to see if our tunnel to both of them is working. So we got one active there. Let's see, 172.16, 2.1, source, 16, 4.1. Okay. So now you see we have the QM idle on both. That shows you that everything's looks like it's working fine. And you should see the same thing in both tunnels. So this is going to 3.3.1. So we knew that was working. And oh, okay. Okay, so 2.2.1. That one is getting the encrypted and unencrypted messages, and we should also see 1.1.1.1 here. And we do. Okay, so you got a tunnel. So you know everything is gold here because here's 1.1.1 as well, which is firewall 1 over here. Okay. Now I just want to point out a couple things here. If I went in here and changed the order, just to show you that these ACLs work like a route map. Or I'm sorry, show run. Okay, so let's change the order of this route map. So let's just set a new one here, call it crypto. And what I'm doing is I'm going to set peer 2 here in front of peer 1. This has the broader ACL that includes the traffic to firewall 1. So this should break the tunnel to firewall 1. Let's take another look here real quick. So I can look, so I set 5, 10, and I still got 20, so I'll get rid of 20 here. Okay. So now, if you look at the ACLs, my bad. You'll see now, firewall 2 is now in front. This contains the whole class B. So it's saying, or I'm sorry, this contains the whole class B. So anything coming from 4.1 is going to hit this ACL first because it's now number 5 in the crypto map, which means there's no way for the router, and this points to peer 2. There's no way for the router to know when to send to peer 1 because order matters. So it's hits this first, so it has no chance to hit this. Let me just show you again. Okay, so this is peer 2 and peer 1, and this is the broader. This is now broader. So let's take a look at our tunnels. Okay, we still have a tunnel up to peer 2, and I don't think I'll be able to bring one up. I'm sorry, it's at peer 1, it claims. Well, let's see here, ping. Okay, that fails. Okay, I expected this to be broken. Why did I lose my... So we got 221. Okay, he still worked there. Brought up the other tunnel. Which is what I expected, he would still work. 3.1. Okay, so this guy still works to there, but he is not going to work because he has no way to know to send the interesting traffic back to firewall 1. I'm not sure why there was the delay there. My bad. Let's say ping. So even though the tunnel is up, as you can see up here, the tunnel is still around. The problem is when you look at the ACLs, is we're hitting this ACL first for the return traffic. So it doesn't know, it's assuming it has to actually send it to firewall 2. This is a problem. So you got to remember, this acts like a route map. Now if we were to change those around, it would fix everything. Let's see here. Oh, I meant to go to the route map, sorry. Okay, so everything happened like we expected. I don't know why there was a slight delay. So this guy still works with the broader ACL, but it broke this guy. Okay, so if we change those back, to 20. Okay. Okay, let's go back and look at our crypto map now. So we're back to the way we were before. Okay. So now, hopefully we'll see if he still works. He still works, and hopefully he'll start working now. And they do. Okay. So that's kind of the big thing. And also, if you're going to test something, the way I'm testing this right now, make sure on your ASAs oops. Sorry, I apologize. I don't remember. Let's do it. Okay. Okay. Make sure you include this command, management access inside. That allows you to manage a device through the tunnel. So without this, I couldn't actually ping from the inside of the tunnel and shoot it over to the test router. So you just make sure you have this. Otherwise, you'll be trying to figure out what's going on if you're doing what I'm doing. Okay, well hopefully that gives you guys a good idea how to set up a VPN tunnel, a LAN-to-LAN VPN tunnel. If you have any questions, let me know, and I will try to answer them. Put them in the comments below. Again, thank you very much. I hope this has been helpful.